Alright, so we're going to find the volume of solid obtained by rotating the region bound by some curves. We're going to sketch the region, find the solid, and talk about the disk, whether it's a washer or a disk. And we're going to do it about a vertical line, alright? Not about the y-axis, but a vertical line. And we're going to use the following example. X equals y squared, x equals 1, about x equals 3. And you notice this is already solved for x. It's going to make the problem simpler. So I'm going to graph these curves, alright? And I have, and it won't be to scale, but I will graph, there's the parabola, x equals y squared. And I'm going to graph x equals 1 here. So our region is right here, and I'll just hash it ever so lightly. We're going to rotate that region about the curve, and this is not the scale. X equals 3 in blue there. Alright, so again, immediately we have to see that we are going to be taking cross sections perpendicular to the y-axis here. They have to be perpendicular to the axis, so our integration is going to have to be with respect to y. So I can quickly fill in the following equation. I have to figure out the cross-sectional areas with respect to y when I slice right here. And I can see by doing this slice, there's an inside hole and an outside fill. So this is a washer again. Alright, and we go through this over and over and over. It has an outside radius and an inside radius. So, and again, since it's the y-axis, I can find these points of intersection. And just by checking integers, I quickly discover it's -1 and 1. So I can fill in the following almost with very little effort. And I know this area of that cross section is pi r o squared, the outside, minus pi r I squared, the inside. And I'm integrating that with respect to y. Now the hard part is figuring out the RO squared and the RI squared. Alright? So if I do that, and I will try to blow this up here, I have those two curves. And we probably can see the RI pretty quickly. 3, 2, 1. That distance is always 2 for RI. Now we can prove it because we know this distance from here is just x. So we have x plus Ri equals 3. Well, x in this case is x equals 1, so this goes to 1. You move it over, you get Ri is 2, just like we saw. But this mindset helps us a lot with the next one. Here is x again, here is Ro. Well, this time I have xo plus Ro equals 3, but x is equivalent to y squared up here. So I can go y squared plus Ro equals 3. So Ro equals 3 minus y squared. And again, whether this is plus or minus will depend on how we're rotating the shape about which axis. Again, drawing good pictures and realizing the x and y distance come off the axes. And then we have to integrate with respect to the variable we're looking for. So I fill this in. And I'll factor out the pi. I like putting pi on the outside. Ro squared minus Ri squared dy. Well, Ro is 3 minus y squared. Ro is 2. And if we're on the calculator section of the AP, we type this in and it gives us a value. Alright? And we can just finish and be done. If we're going to integrate this by hand, and I'm going to give you guys a chance to try that, and I'll show you my calculations, we got to remember when we do this integration by hand, the binomial squared becomes a trinomial, and this is a 4. And again, there's some simplification we can do here, and I'll show you that on the next page. You want to watch for even or odd functions. This will be an even function with respect to the limits of integration. With that said, I'm going to just go that I'm using my calculator. Well, I'm using the answer on my other sheet. And that the volume here should come out to be that. I'm going to flap up or throw up here the hand calculation. And if I do that, you'll see that right here is the step we had. And I had the calculation shown over here, but here's the step we were at. I square the binomial to get the trinomial here, minus 4. And I combine like terms and I put in descending power. And then you kind of see some cross steps here. I know since this is y to the 4th minus 6y squared plus y dy, this is an even function. So I'm going to change the limit of integration 0 to 1 because I know that the volume rotated here, this blue, around this axis, if I go around the x-axis, it's going to be the same as that region here, which I did not shade. So I can just do it twice. And when I do that integration here, you'll see that I come up with 32/5 pi. Again, doing solids and regions, the biggest decision is whether it's a washer or a disc, and then it's doing the right axis of rotation. If it is a vertical line, it has to be dy. If it is a horizontal line, it must be dx. Keep practicing.